Assalamu alaikum wa rahmatullah. Regarding soil quality and management, we have already discussed that what are those indicators which are used to assess the quality, and then we discussed the needs of the management, why we need to manage the soil quality. So we had a detailed discussion on that. So today we'll talk about the components of the soil which can be managed, and we'll talk about the practices uh, which are used to manage those components. First one, that is the soil management. But before going toward soil management, we must know that what is actually quality of soil. What are the types and to which extent we can manage those quality parameters. For example, we have here two soils. Uh, this is A soil and B soils, and both have different quality levels, and these quality levels, they are inherited, and we say that these are inherent soil quality parameters, or whatever you name. We cannot convert soil A to soil B. We cannot do that, and neither we can do soil, or we can change soil B to soil A. It means there are certain limits in which we can manage the original quality of that soil, and the things which we can manage, that is in dynamic soil quality. It means that quality can be changed with our management practices or with some amendments, and we are interested only in dynamic soil quality, not inherent soil quality, because it's very tough to change those quality parameters. What we can change, soil A, this zigzag. It means we have this or these limits. Between these we can manage. If we have good management practices, we may improve the quality. If we have poor, then we will decrease the quality. But uh, that is actually a very limited or defined uh, level where we can manage the soil. And the second, the quality, the soil B, which is relatively poor quality soil. And when you have poor quality soil, it means you have more capacity to change, because as you are at lower level, you have more margin to change. For example, if you are getting uh, 50 marks out of 60, so with hard work you can change up to 52, or if you are not working very hard, you can go 48, or you can go for 55 with more work. But if you are getting 30 marks out of 60, and you can very easily go up to 40, 45 with the little hard work. So it means when you are at lower level, you have more potential to improve. However, that is again limited. You cannot change, as I earlier said, B to A, because those have a lot of margin between it, and you cannot do that. Of course, if you have another soil which is very near to A, like here, uh, soil C, so you may change, or you may convert to soil A level, but in case of B soil, you cannot, because we have certain limits. So one should be clear about that. What what are your defined levels where you can change the quality of soil? So the soil management aim is, whatever you have soil quality, you have to sustain it. This is the original soil quality level, or you have to improve it with good management practices up to certain limits, and then if you are not going for those good management practices, you can degrade the soil. So our main purpose is either to sustain the soil level or to enhance the uh, quality of soil as per our resources or as per our capacity. Soil management is to use agriculture soils for optimum crop yields and at the same time maintaining or improving the capacity of soil to provide essential functions in the ecosystem. So we have to of course utilize agriculture soils to have more yields or at least optimum yield which are uh, profitable for the farmers, but at the same time we have to improve the capacity, we have to sustain the capacity of soil so that uh, it can provide all the essential functions to the ecosystem. For example, the carbon sequestration, enhancing the organic matter, and providing the nutrient to the plant. So we have to keep it uh, going for even our next generation. So that is management. By managing the soil, farmer can add very easily because they have very limited land and they cannot enhance the area, but they can add production. They can have some increment in the crop production without adding some acres. They can add profits without adding inputs. So because the management is not mainly that you are adding some amendments, it is basically whatever you have to manage it in such a way that it sustain the soil and it give you the similar yield. So it means you can enhance the profits with little inputs. Then add sustainability without adding risk. So you don't have any risk, but you are sustaining your soil for your next generations, for humanity, for environmental perspective. So, looking at the goals of soil management, we have two main goals. The first is high crop productivity and quality. We need good yields. We want to make money from the farms, and we want to keep farm stay in business, because if you are not getting sufficient amount of profit from that farm, you cannot sustain it. So you have to keep the farm. You might have heard that the people from the rural areas, so they are migrating toward the cities. So so one thing is that they are not getting sufficient profit from that farm to sustain their good life. So that's why they are moving away from those land areas. Uh, if it will continue, then of course those farm will not be in the business, and we will have a massive shortage of food and other items. So this is very important to keep the farm in business, and for that you need a sustainable system which can sustain the quality of soil or improve the quality of soil and can give you more profit or sufficient profit. The second is clean environment. When we are talking about the management, we want to save the quality of soil and animals living on that, reducing the reducing the chemicals, especially the toxic chemicals, and then to prevent the runoff, soil erosion, to save the upper surface of the soil, and of course to recycle the nutrients in the system so that we may not need to add other uh, inorganic or synthetic fertilizer in a huge quantity. Because if you are uh, not recycling, then you will have to add more inorganic or synthetic fertilizers, which are of course not good for the sustainable agriculture in different ways. Coming toward the components and the practices, of soil quality management. Uh, Now we have clear in mind that what is actual soil and what can we do, and to which extent we can manage the soil. Uh, in general, the farmers they are not thinking about that. If they are very poor land, so they want to add a lot of inputs in those farms to get the maximum yield equivalent to that of the high quality soil. So which is not possible. And if it's possible, even not profitable because we have to keep the profit. So whenever we are talking about managing the soil, so we must be clear. So there are seven components of a soil which can be managed, and we have various practices which can be used to manage uh, those components of soil quality. We will talk one by one about that. The first one, that is enhancing organic matter. What will happen if we will enhance the organic matter? It will of course improve the soil structure. It will improve the drainage. The both are very related to each other as well. If you have good structured soil, then of course the drainage will be better. Hold the moisture, because you have a good structure of soil, you can have a better holding of moisture, mean there will be optimum infiltration and there will be less leaching. Then it will of course provide the nutrients, because the organic matter, they are rich in nutrients, and as they decompose and they form the humus, and then they have ability to exchange the cation, because the humus has negative charge and that can exchange the cations, which is very important that the they have ability to hold the nutrients when they have negative charge. Uh, we may have a discussion in in future lectures as well on that. However, we cannot enhance the organic matter in all cases. We have some hurdles, uh, lack of organic matter to be added. So if we want to add some organic matter, we don't have sufficient amount of organic matter. Of course, we can add whatever we have, but uh, the available amount of organic matter perhaps is not sufficient to get sufficient yields. And perhaps that is the reason that the organic producers, so they are subsidized, because they are not getting sufficient yield by using organic matter, and uh, that is relatively uh, expensive. It's not cost effective. Then we have a high temperature in mostly in or in many agriculture areas, uh, and we have also arid land areas. We have very less rainfall. So in these conditions, it's very difficult for soil to maintain or to keep the organic matter for a longer period of time. Uh, then we have intensive agriculture. We are growing one crop and then again tillage and then again another crop. So that is also not contributing to enhance in organic matter. And we have to do that because we have to feed the population. We have to fulfill the increasing demand uh, of the people. So these are some hurdles which are uh, or which should be considered when we talk about enhancing the organic matter. We can monitor the organic matter by physical condition of the soil. You can observe even the soil having tweaks or the part of organic matter in that. You can assess by microbial populations. Uh, by doing that, we can also observe that how much organic matter is there and how much we have to add. Then, of course, we can exactly measure the organic matter present in the soil in the form of organic carbon. We can measure, and then we can monitor that how much organic matter is there and how much can be added and how much must be added to the soil. The second component which we can contribute, that is to prevent the soil compaction. If we prevent soil compaction, we will of course improve the root development, uh, because we will eliminate the hardness of the soil, and it will give specific or sufficient space for the root to grow. Then we will have enhanced the soil aeration. This will not only give the oxygen to the roots, but it will also ease of root development, as I mentioned earlier. Enhance soil available water, of course, that will have more capacity to hold the water in the soil. The water infiltration rate, that will be enhanced, because if you have compacted soil, the water will not be absorbed in that surface, and it will be run off. We will decrease the bulk density, because when the soil is not compacted, it has more volume, and the bulk density is mass divided by volume. So it means the bulk density will be reduced, and the reduced bulk density is better for agricultural crop production. Then, if we have a compacted soil, there will be more runoff, and there will be a sediment losses, and we know that the sediments have nutrients, and there will also be nutrient losses. So in both cases, uh, we will have impact on agriculture production. Decreases surface runoff. uh, of course the water will not move uh, as fast, because a significant amount of water will be absorbed into the soil, and the surface runoff will be reduced. And of course, it will improve the soil structure, because you will have more pore space, and there will be better aggregation in the soil. So, how can we do? Because uh, we can, as mentioned in the very beginning, that we have certain limits. So, what we can do in agricultural lands, we can have a controlled traffic farming. We have other options as well, but the first main option which we can use in modern agriculture, so that is controlled traffic farming. So what is this farming? Controlled traffic farming is a farming system built on permanent wheel tracks, where the crop zone and the traffic lanes are permanently separated. So the lanes of crop production and the uh, wheel lanes, so they are permanently settled. So normally they are very straight line, by using the remote sensing and satellite information. The agriculture equipment or machinery is controlled in the field, and it is uh, uh, very important or very significant to use this controlled traffic to reduce the compaction, because you will have specific lanes, and all the machinery, whatever you have, the sprayer or the cultivation machine, or then you have the harvester, so they will move on those lanes again and again. So in general concept, we say that there will be more compaction on that side, because we are moving our equipment and machinery again and again on the same lane. But actually it's not like that. So whenever you run a machinery once on the soil, the 80% compaction is completed. So it means if you have equipment field like this, which is not controlled, this one is not controlled, and you have run the machines without any control traffic system. So it means wherever there is a lane, you have compact the soil 80%. And if you again run a traffic on the same lane, so there will be 5% more, and then again, then maybe 5% more. So in this way, uh, you will have a whole area that will be compacted. Our maximum area will be under compaction. But if you have a controlled lane, so you have specific lane and all other area is very good, and you can grow crops there, and there are certain benefits. For example, overall compaction is very less. You will have more porous soil because you have a significant area which has never been under traffic. More efficient farming operation, of course, this is modern. If you have machinery and you can work very easily and very efficiently on the same lane, of course you can save energy. You don't have to run the machinery again and again by using different ways, and then in the end you have to uh, till it again when you are preparing the soil for the next crop. So in many ways it saves energy, and of course there will be less greenhouse gas emission because you have efficient systems, and efficient system always help to reduce the greenhouse gas emissions. But of course there are hurdles in that. Poor compatibility of tram line based traffic layouts with surface water control structures and revegetation patterns in the landscape. So there are the compatibility. We don't have a similar kind of machines and irrigation system. So so that's why that may hurdle. But of course, it is happening in the different parts of the bird. But in our parts, it's a bit difficult because we have very small holding, we have very small farm, and it's not very easy to run the machine in this way. Then we have increased soil erosion risk uh, when surface cover is low and the topsoil is compacted by grazing, especially gully development and where traffic patterns are across the slope. So the erosion is also because you have a certain compacted lanes, and then water will move very fastly on that, and that can have a gully formation, and there will be more erosion. So this is also a hurdle. Satellite dependence, risk of serious interruption from downtime of navigation system. If you have some interruptions in the satellite uh, systems, and then you will have issues. So it means you have maximum dependency on the satellite. There will be more electronic management and lack of driving skills. Of course, when you have a big machinery and based on the satellite system, less staff is trained, and especially in the rural population. The next component which we can manage, that is to minimize the tillage. Uh, Tillage is a mechanical modification of soil structure. So we do in different ways. We have simple cultivator, we have disc harrows, we have rotavators, and many kind of things which we use. All this is in the tillage. Why we do that? Soil conditioning, because we have to prepare the soil for the seeding. Then weed pest suppression, we do to cut down the weeds. Residue management, if you have a remainings of residues of like rice or wheat or any other like cotton, then you have to manage them in the soil. You have to till them, rootavate them into the soil. Sometimes you are adding some amendments and you have to mix it. For example, the fertilizers uh, and the organic manure, you have to mix it. Then you need tillage. And of course, for land farming, you want to prepare the farm in different way, the bonds, the borders. You sometimes you have to reshape the farms as per your requirement. So that's why we do that. We can monitor soil physical condition. When we say monitor, it means in different ways, whether it's a need of something, whether it's already in excess. So monitor just to monitor the level and to suggest. So soil physical condition can suggest to us that how much tillage has been prepared, has been done, and is there any crop residues in that. Uh, then nature of crop residues, what kind of residues you have and what kind of tillage is required. Weeds population, if there is a huge population of weeds which must be cut down with the uh, cultivators or with the tillage equipment. Microbial population, if you have uh, assessment of microbial population, then you have to consider that whether the tillage will be benefit for tillage will have benefit for that or not. The nature of equipment to be used for sowing. So whatever or what kind of equipment you have to be used for sowing. If you have drill, which must need some conditioning of soil, of course you have to till it. But if you have direct seeding drill, you might not need any kind of soil conditioning or preparation. So in managing, we can minimize the soil tillage. So it doesn't mean zero tillage. It means we have to reduce the excessive tillage, avoid excessive tillage. So in this way, we can manage. Of course, tillage, as we discussed earlier, we have a lot of things to do with tillage. So we cannot eliminate it. Of course, there are some examples or suggestions, but we still need it. But we can minimize. If we minimize, then we can improve the soil aggregation, which we are breaking the structure again and again by tilling operations. Improving soil biological activity will improve because you are not exposing the or you are not interrupting the biological activities in the soil. Uh, when you use a machinery for tilling operation, you have also compaction issues. But if you don't have a much tillage, so you will have less compaction, less soil carbon losses, because if you have more tillage, you have more oxidation of carbon to carbon dioxide, and then that which will be released to the atmosphere, and there will be losses from the field. And of course, minimize the loss of organic matter, because when you expose the soil, there is aeration, more microbial activity, and there will be a rapid decomposition of organic matter. So this may vary to a certain extent in different conditions, but in general, it's happening like this. So that was all about today. So first part, and then we will talk about the next part, the other components, and we will discuss that what kind of practices can be uh, done to manage these component of soil. Thank you very much.